So, welcome everyone here. I'm going to talk about data quality, which might sound pretty boring, at least I get this feedback from a lot of coworkers, but it's still very important, and it's something you should constantly think about and incorporate into your daily work. So, let me start shortly with my motivation on this talk. So, until a year ago, I worked at Prezi, in Prezi's data infrastructure team, and our responsibility was running a 60-node Hadoop cluster and making sure that all the logs that our services and our users ever created were shipped at the right location, they were processed. This all happened in time. And yeah, we did that with a lot of data. It was like petabyte-scale, and yeah, we had a huge Hadoop cluster. But then a year ago, I changed, and I went to Secret Sauce Partners, which is a completely different company. So it's like 10th of the size of Prezi, and we have a completely different business model, completely different product. And ever since, my dear teammate in Prezi kept asking me that, oh yeah, how big is your data now, and how many nodes do you have in your Hadoop cluster? And yeah, first it was kind of funny, but after a while it got pretty annoying, because yeah, maybe my data is not as big as his, but I have other challenges which are just as fun. And yeah, so I was talking to them that yeah, but for us, data quality is the real thing, because we build a product that completely powered by data, so we have to make sure that everything is precise, correct, because that's what our business is using. And so this conference arrived, and I decided that, okay, I'm going to submit a talk, and that's going to be about data quality. And then I showed the abstract around to my colleagues, and I wanted to some feedback. And then my other dear ex-Prezi colleagues, Zoltan, who just gave a talk on Spark in the morning, told me that, oh, your job must really suck if you come to a conference and whine about data quality. But still, I don't think that's the case. So I think that's a really interesting challenge that you should solve, and there are no silver bullets. You have to use your common sense and tricks and tips and try to achieve as good data quality as possible. So yeah, as I mentioned, we have these data quality issues or like challenges in Secret Sauce Partners, but I'm not sure if you know what we actually do. So, yeah, as you heard in the introduction, we work in the fashion industry, which means that we create solutions for apparel merchandisers, so basically websites who sell clothes, to enhance their user experience. We have actually two products. One of them is Fit Predictor. This has been around for years. We have, I think, tens of partners having this service from us. What it does is that if a customer goes to a certain product, for example, this amazing dress, and he or she wants to buy it, then we help them to pick a size. And this prediction is based completely on data. So we know what this user purchased in the past, maybe from this brand or maybe from another brand, but still we can use this information to infer what size of this certain brand, of this certain item that user should buy. So yeah, this has been around for years, and as I said, it's completely based on data. So we get product information and historical purchase information from these merchandisers, and then we build basically a recommendation system based on that. So if you have ever bought a size, let's say M from a brand X, then we know exactly that if you want to buy brand Y, then how the sizes relate, and we know this because we know how people purchase, which size they purchase from what brand. Yeah, and our second product, which is very fresh, it was released like 2 weeks ago. It's called Style Finder. It's again a completely automatic tool to help people discover the inventory of a certain partner. So imagine that the merchandisers we are talking about, they have tens of thousands of dresses. So only female dresses, they have like 10,000 or 20,000 on their site. So if someone goes there and says that, okay, I want to buy a blue dress, a blue short dress, but where can she start? So we help them with Style Finder. So you can pick a dress. This on the left-hand side, that dress is blue and short, so maybe this is quite what our user wants. But then we can show her or him the very similar dresses in the inventory. And this is all based on visual recognition and no setup or registration or no manual interaction needed. This is all just based on machine learning algorithms. So yeah, that's what we do. And yeah, as I try to emphasize, both products really rely on data. So it's crucial that what we get from our partners, which can be considered as third-party data sets, how we integrate them into our backend systems, because that's where it has to be very precise, even though the source wasn't clean enough or perfect enough. We still have to ensure that our service quality is okay, because if it's not, then basically we have an outage and we can't afford that. But on the other hand, we are a software as a service company. So there's another aspect as we talk about data in our case, and this is that we collect user activity logs, because we want to know if the users like our user interface, do they understand the layout on our little widget. This is not a big widget, so it's like a very small part of the website, but still, had they noticed it? Could they use it? Could they understand how it works? And we have to drive business decisions based on that. So both are very, very important, because you don't want to have outages, for sure, but you also want to make great and data-driven business decisions. So both are very important, and in both cases we need great quality data. But I'm going to focus more on the first case, so on how we deliver these feeds or the third-party data sets into our backend system, because first, this is where I'm working most of the time, and second, because I think the other is a bit more understood. And for example, we use a very good open source tool for that, Snowplow, and it addresses most of the cases, most of the issues I'm going to mention here on the next slide. So yeah, if you want to talk about data quality, first we should somehow get on the same page, so let's define it. And yeah, my best idea to define this term was to go to Wikipedia and get a definition from there. So that's what Wikipedia says about data quality. So there are many definitions, first of all, but the most general or more generally accepted is that if the data is of high quality, if it's fit for their intended uses in operations, decision making, and planning. So what I'm focusing now here is more of operation and decision making, but I think it's easy to understand that it's also important for planning. And what the first part of the sentence says, that it's fit for their intended uses. This means that when you build a system and you rely on some data, then you have some assumptions about that data. And I think in the beginning it's very easy to keep these promises and these assumptions, but how the time passes by, your data may change, or you may change your system, and you assume again something that might not be true, but you just forget that you had some contract between the data and the system. So yeah, that's what's really tricky here, I think. Because in some certain point of the time, it's easy to have good data quality, but with time, it can decay very quickly. So yeah, and then when I was thinking about this presentation, how should I approach data quality, and how should I somehow bring closer to people and emphasize its importance, then I realized that it's not very far, at least in my opinion, from code quality. So if you're an engineer, then probably you have heard about code quality, you were but with like you should write better quality code and things like that, which means that, for example, you should have high test coverage, or you should use good practices like not using mutable variables when it's not like it's not necessary, because these make your code more readable, more maintainable, and somehow these ideas I think we should apply to our data systems, either directly or indirectly. For example, the test coverage. Of course, it's nice to test your code, but also if you think of data as a whole system, and the end usage is basically the end data set that you have, or also the immediate data sets that you have, you can basically cover them not by test but with monitoring. So if you know what you expect from your data, you can trigger an alert if that doesn't hold anymore, and then you can go back and see what has changed. Is it something in real life, like people just heard about your product and they just started using it like crazy, or you broke something, or it's an attack? So you should know what you expect from your data, and provide some kind of coverage, maybe test, but more importantly, in case of data, monitoring. Yeah, so I think this was the key idea when I tried to collect all the best practices and tips that we did. And yeah, let me share these with you, what worked for us. Maybe some of them are trivial, but sometimes in real life situation, these trivial things somehow get lost in a way, and after a while you have to still struggle with them. Like this first point. So yeah, my first tip for you is enforce schema, and this is like, yeah, no trick. So yeah, it's very trivial, but in both companies I worked, that wasn't the case. So we had unstructured data. In Prezi we had unstructured logs, and then it was a big struggle to migrate the system to structured logging. Or in SSP, as I said, we work with the partners' data. So we rely on third-party data that our clients pass to us, and sometimes it's very hard to ask the perfect data from them, because they are not necessarily tech savvy, and they don't want to spend time on doing what we ask for, and it's also a business decision how far we want to go to enforce these things. And yeah, at the very beginning, where the company was just starting up, we accepted any kind of data, and we have really weird and crazy CSV files arriving to our system still today, and it's really hard to deal with that, but we have to. So we can't go back after 2 years that, okay, we gave you good service, but please now change the data that you sent to us because we want to scale. That's something that your business people will just say no. So yeah, I would add to this tip that enforce schema as early as possible, which can be also as early in your company's or in your product's life, but also if you already have to deal with legacy, let's say legacy or unstructured data sets in your pipeline, as early as possible, try to enforce some schema. What we do currently is that after the data comes in, we try to bring it to a standard format, and then convert it to Avro, which enforces some schema, and then we put this through our pipeline. And then we can catch the data flows as early as possible, and maybe get back to the partners that, hey, today you sent us a lot of like weird things, let's look into it. The second one is, I want to refer back to my previous slide about code quality comparison. So you should test, and you should test your data pipeline code. And maybe that you say now that, oh yeah, that's trivial too. But again, in both companies I worked, I saw big scripts being in production, doing the transformation part of the ETL process, which is which was basically not testable. I mean, you can test pip, but I haven't really seen a living person who did that at a workplace. And so it's just, so you can't rely really production data on something that's not tested. I mean, maybe it's just me, but I don't trust my code if it's not tested. So yeah, I think that's important, and not many people do that. But an additional tip next to this, that pick a tool that can help you achieve the previous ones. So, for example, as I mentioned, we had pig scripts doing this transformation into production ETL. And of course, I didn't start to write tests to these pig scripts. So we picked the tool, in this case Spark, to write tests. We migrated our code there, plus it enabled us to add really easily unit tests and integration tests and all kinds of tests. So we don't have to worry about the quality of the code and the precision of it. And one more thing about testing, that it's not just a test for your code if it has a bug or not, but also documents, it's a documentation for your state of your data. So it happens with us very often that we get some kind of values for, let's say, sizes in the product data sets from our partner. And on the next day, they introduce a new brand or a new product that has different sizes, and we can't handle that in our transformation. So when I see this, that we dropped something, I can go back to my code, to my transformation code, and I can add these new cases. And I can see later, also in my Git history, what happened there, why that happened, why I added these new things. And so it's much easier to maintain this whole pipeline. So yeah, pick the right tool, because yeah, testing is important, but if you don't use the right language or the right technology, then it's going to be a pain in the ass. And of course, yeah, again, I can't emphasize it enough, monitor. Do monitoring, and if possible, do monitoring on your whole pipeline, because then if something breaks, it's going to be easy to identify where that broke. So maybe it was in the raw data, maybe it was somewhere in the middle because, I don't know, your machine died, or you lost some spot instances on your EMR cluster, or maybe it was just the last step, the very last step failed and something didn't load to your data warehouse. It's going to be much easier to debug, and also you can learn a lot about your data, how that evolves even in your pipeline. So don't forget monitoring, because that's how you can notice anomalies or trends even, and that's also crucial. Okay, so a quick wrap up. So what my point is, and I want you to remember when you leave this room, is first that you should think of data quality as first-class citizen in your applications, especially if it's fueled by data, or also if you are in a business that wants to drive data-driven business decisions. That's very important. You have to be certain that the data you present to your stakeholders or to your users is correct and precise, and they can rely on that. And also, if you have an ETL process, don't treat it, it's just like I don't know, data pipeline, who cares? It's also an application, so treat it in this way. Write tests and monitor, and treat it as any other like API or service, because that's how you can really fulfill the first point up there. Okay, so thank you for your attention, and if you have any questions, then I'm more than happy to answer.
Suppose that I would like to upgrade my look and feel and have some much more badass lumber floats. So in your system, do you have any kind of measurements how many data is accessed? So, I access your page, select my shirt, and so how many queries do you execute? How many data do you move in your cluster?
I'm pretty sure we have, so somewhere you could get these informations, but it's not something that we, or personally I watch every day. But of course we have monitoring about how users use our service, but it's also tricky because we are integrated in websites, so it's not our own service. So it also depends on the traffic or of our partners. So we have really high traffic partners, and we have like smaller ones. But yeah, we have some aggregate numbers. I can't recall them on the top of my head, but yeah, we do have something like that.
Cool. The second question would be about the M4 schema.
Yeah.
So on the market, we have several different kind of data storage systems, which allow the flexibility to have not too strict, say like document databases, column-based databases. So you're trying to tell us that on those systems it's much more difficult to enforce the quality?
Actually, the database behind our feed predictor service is MongoDB, and the reason is this was a decision years ago when this was an experimental project, and at that time it enabled the team to move quickly and change things quickly, but recently we are really struggling with that because it can't really handle the kind of things we do now, and yeah, there's a mess in it sometimes, and we have to ensure the schema somewhere before the data arrives into that database if we want to ensure that everything is consistent. So yes, I think it makes your life much harder if you don't enforce schema at all.
Right, and so if you could restart it from scratch, what would you choose as your your storage system, or what would you advise?
Actually, that's not really my field, so that's the backend system guys who do those decisions. But as far as I know, so we want to keep MongoDB just to store the data, and so that should be the database where we read from. But everything else, for example, updating all the data that gets into that, or transforming things, that would happen somewhere else. So we are moving into this direction, but I think that's a bit different area from what I'm working on.
Thank you so much.